We're going to finish our discussion of limits for section 2.1. At the bottom of your notes paper, you see a piecewise function. We've been asked to compute the limit, the left-hand limit, the right-hand limit, and just the limit as x approaches 0, 1, 2, 3, and 4. That's what we'll do here. So at x equals 0, I want to find the limit as x approaches 0 from the left. Let's get this. That means coming at x equals 0 from the left, but over here there isn't even a function to follow. So it wouldn't be appropriate to actually talk about the limit as x approaches 0 from the left, because f of x does not approach 0 from the left. Numbers to the left of 0 are not in the domain. So how about the limit as x approaches 0 from the right? I can do that. You can see I'm going to get to this value up here. That's y equals 1 is my limit. Another question I might answer is, what is f of 0? Well, that's where I have the colored in dot. That happens to also be 1. And then the big question here, does the limit as x approaches 0 exist? And if it does, what is it? So here we would say the limit as x approaches 0 of f of x is 1, because the left-hand limit doesn't make sense to talk about. There's no x values to the left of x equals 0, but the right-hand limit is 1. When x equals 1, I can talk about the limit as x approaches 1 from the left. I'm approaching that open circle where y equals 0. I can talk about the limit as x approaches 1 from the right. I'm approaching that point at 1, 1, so the y value is 1. The actual colored in dot is at 1, 1, so y value is 1. That's function valued. And the question here is, does the limit as x approaches 1 of f of x exist? Well, the limit from the left was 0 and the limit from the right was 1. So the limit does not exist. That's what theorem 3 was all about. As x approaches 2, I can talk about the limit as x approaches 2 from the left. You can see I'm headed for that open hole whose y value is 1. As x approaches 2 from the right, I'm approaching that same open hole whose y value is 1. And it turns out that the actual function value comes from that dot up there, f of 2 is 2. But the question on the table, does the limit as x approaches 2 exist? Well, the limit as x approaches 2 from the left is 1. The limit as x approaches 2 from the right is 1. So the two limits match, and we say the limit as x approaches 2 of f of x equals 1. At x equals 3, I can talk about the limit as x approaches 3 from the left. You can see I'm headed for that dot whose y value is 2. I can approach x equals 3 from the right. Again, I'm headed for the same spot whose y value is 2. The actual function value also comes from this same dot. F of 3 happens to equal 2. The question, does the limit as x approaches 3 of f of x exist? Well, the limit from the left was 2. The limit from the right was 2. Since the limits match and they both equal 2, the limit as x approaches 3 of f of x equals 2. And here we go at x equals 4. I can talk about the limit as x approaches 4 from the left. I'm headed for that spot whose y value is 1. Now when I talk about the limit as x approaches 4 from the right, here's the right. There's no x values over here to talk about. There's no function to approach on, so it doesn't make sense to talk about the limit as x approaches 4 from the right. F of 4 happens to be 1. We can see that colored in dot there. And the question is, does the limit as x approaches 4 exist? And if it does, what is it? Well, the limit from the left was 1. The limit from the right doesn't make sense to talk about since numbers to the right of x equals 4 aren't part of the domain. So we say yes, the limit as x approaches 4 of f of x is 1.